Okay, this is another hydrostatic force problem. This one's a little more challenging. Make sure. Okay, so we've got a triangular dam here. Here's our water level. And it's triangular. It's 10 meters wide total for the triangle, which means, of course, it's symmetric. Each half will be 5. And it's 4 meters deep. Here's our water level. Always put our x-axis at the water level. We do the more complicated version. Sometimes you may want to change that, but typically that's what you want to do. Put the y-axis going down, so positive y goes down. It makes things a lot easier. Now we're going to pick some random spot down here. I like to call it y star. And we're going to pick out this little sliver here. That's approximately rectangular. As we take the limit as delta y goes to 0, that's how thick it is, that will become rectangular. And then when we do our integral, everything will be fine. Okay, then that little rectangle there, we need to find the area of that. Remember, force is pressure times area. So I've got this distance here. I'm down at some level y, so this distance here is some x that will depend on y. So let's call this distance here x. So the whole thing is 2x wide. That will depend on y. You can see as we get down here, x, our distance across, will be 0. Up here at the top, the distance across would be 10. So x would be 5 here, x would be 0 here. And we're down at some y star. Our thickness is delta y. Okay, we're going to use similar triangles here to figure out x in terms of y. Our integral is going to be in terms of y. I'm going to have a dy, so I need everything to be in terms of y. So we draw these similar triangles when the whole thing is 4 and this side is 5, and compare that with this triangle down here, this triangle. When this side is x, this length right here is 4, so this length would be 4 minus y. And now we have these similar triangles. I really wish my camera would stop autofocusing. Okay, so setting up our proportion, 4 relates to 4 minus y in the same way that 5 relates to x. My goal here is to solve for x. So we'll get x, when we do a little cross multiplying, will be 4 minus y times 5 divided by 4. We can go ahead and distribute that if we want. It doesn't really matter. It's actually easier if we leave it like this, or we could turn that into 20 minus 5y over 4, or we could turn that into 5 minus 5/4 y. Now, this rectangle here is 2x wide. That's why it's easier to leave it like this. So my area will be twice x, so that will be 4 minus y times 5 over 2. Instead of over 4, I've doubled x times delta y. That's the area of this little rectangle. Then the force down at that little level at y star will be the pressure down there times the area down there. Pressure is rho times g times your depth. My depth was my y star. So that means my force from just this little sliver here will be rho times g times y star times my area, which I just found here, And I'm going to write that 5 over 2 just as a 5/2. It'll be easier in the long run. Delta y. That's the force from one little rectangle. So the total force, we're going to build our Riemann sum now, is approximately the sum over all the different rectangles we would do here, call it all the F stars. And we take the limit as delta y approaches 0. The delta y turns into a dy. The sum becomes an integral, and we get F total equals the integral from smallest y to biggest y. This was y equals 0, that's the x-axis. This is y equals 4 of rho g y, because that's our variable of integration now. 4 minus y, 5/2 delta y. Or we took the limit, delta y becomes dy. Okay, the 5/2, the rho, the g, those are all constants. They can come outside the integral. So 5 rho g, we'll have the integral from 0 to 4. I'm going to go ahead and distribute this y. 4y minus y squared dy. That was 5/2 we pulled out. Now we just do the integral, the definite integral. Antiderivative of 4y would be 4y squared over 2, or 2y squared. Antiderivative of y squared will be y cubed over 3. Evaluated from 0 to 4. Everything's 0 at 0, so we don't worry about it. We just plug in the 4, and we get 5/2 rho g times, let's see, that'll be 16 times 2. That'll be 32 minus 64/3. And we could clean that up if we wanted to. Rho, of course, is 1,000 kilograms per cubic meter. G is 9.8 meters per second squared. We plug all that in and we get newtons. I'll let you guys clean that up on your own. That's our final answer.